Welcome back to our series, AI for Beginners, Step-by-Step Journey from Novice to Pro. Please subscribe to our channel so we can make more exciting tutorials like this. What a journey it's been thus far. We've explored the realm of AI, debunking myths and uncovering realities. Together, we've navigated the intricate paths of algorithms, discovered the vital role of data, and even set up our very own toolkit. And let's not forget the thrill of creating our first basic classifiers. We've learnt that AI is not just about machines, but about the art of teaching machines how to learn. We've realized that the heart of AI is not just in the coding, but in the data. And we've seen that the power of AI is not just in its ability to perform tasks, but in its potential to evolve and improve. As we continue our journey, we're about to step into a realm that's a tad more magical and intriguing. So tighten your seatbelts and let's dive into the fascinating world of neural networks. Today, we're venturing into the fascinating world of neural networks. As we embark on this part of our AI journey, it's essential to remember that the inspiration for these networks comes from a source that's closer than we might think, our very own human brain. Picture the brain with its billions of neurons intricately connected, forming a vast, complex web. This is the blueprint for neural networks in the realm of artificial intelligence. These networks comprise nodes or artificial neurons that are linked together, mirroring the structure of our brain. But what are these artificial neurons and how do they work? Well, in the simplest terms, they're computational units that take in inputs, perform calculations, and produce an output. Much like how our own neurons receive signals, process them, and pass them on. Now imagine walking into a room and flipping a switch. The light turns on. It seems simple, right? But behind that straightforward action is a complex network of electric circuits. Similarly, when we feed data into a neural network, it travels through multiple layers of these artificial neurons, gets processed, and ultimately results in an output. This could mean recognizing a face in a crowd, understanding spoken words, or predicting the stock market's trends. The possibilities are truly boundless. As we delve deeper into the world of neural networks, it's important to understand that these networks are not static. They're dynamic and capable of learning from experience. They're trained using vast amounts of data, and over time they learn to improve their accuracy, refining their output with each new piece of information. Much like a child learning to ride a bike, the neural network might not get it right the first time, or even the second. But with guidance, repetition, and time, it becomes better, more precise. That's the captivating beauty of neural networks in AI. They evolve. Neural networks in AI consist of nodes or artificial neurons linked together. They're more than mere mathematical models. They're a testament to human ingenuity, a reflection of our quest to replicate the intricacies of our own brain, and a stepping stone to a future that's brimming with possibilities. So let's keep exploring. Imagine walking into a room and flipping a switch. The light turns on, illuminating the space around you. This simple action, an everyday routine for most of us, is actually a result of a complex network of electrical circuits working together. The switch acts as the input, the light as the output, and the electrical circuit as the pathway connecting the two. Now let's take this analogy and apply it to neural networks. The input here is the data we feed into the network. This data could be anything from images and text to sound waves and numerical values. The output, on the other hand, is what we want the network to learn or predict. It could be recognizing a cat in a picture, translating a sentence into another language, or even predicting the stock market. Between the input and output lie several layers of nodes or artificial neurons forming a network. Each of these nodes is like a mini decision-making entity, processing the data it receives, applying certain mathematical operations, and passing on the result to the next layer. This process continues layer after layer, each one refining the data a bit more until we reach the final layer, which gives us the output. But here's where it gets interesting. Each node in the network has a certain weight associated with it, which determines how much influence it has on the final output. These weights are not set in stone, but are adjusted during the training process, as the network learns from its mistakes and improves over time. So, when we feed data into a neural network, it travels through multiple layers, gets processed, and ultimately results in an output. It's like an intricate dance, a symphony of computations, all working together to make sense of the world around us, one data point at a time. And that, in a nutshell, is the functioning of neural networks. A complex yet fascinating interplay of data, computations and learning, all aimed at helping machines think a little more like us, humans. These networks are trained using vast amounts of data. Just as a teacher provides students with information and exercises to help them grasp a subject, neural networks are fed large datasets. These could be images, sound files, text, or any form of data that the network needs to understand. Each piece of data comes with a corresponding label or answer. When the network is initially exposed to this data, it makes a lot of mistakes. It's like a student on their first day of learning a new language. They might not understand much, and that's okay. The important thing is that they're trying. But here's where it gets interesting. After the network makes a prediction or an attempt, it gets feedback. It's told whether it was right or wrong. And just like a diligent student, it takes this feedback to heart. Remember those interconnected nodes we talked about earlier? Each connection has a weight associated with it, which determines how much influence one node has on another. When the network gets feedback, it adjusts these weights. This process is often referred to as backpropagation. It's like the network's way of studying and revising. Over time, as the network is exposed to more and more data, it begins to learn. It starts making fewer mistakes. It becomes better at identifying patterns and making accurate predictions. It's like a child gradually mastering a language, going from stammering attempts to fluent sentences. With guidance, repetition, and time, they become better, more precise. That's the beauty of neural networks in AI. They evolve. And just like a child, they don't stop learning. As they're exposed to new data, they continue to adapt and improve, always striving for accuracy. It's a never-ending journey of learning and growth. Stay tuned as we delve into the magic of deep learning in the next scene. But for now, let's take a moment to appreciate the elegance of this learning process. It's not just about numbers and algorithms, it's about growth, adaptation, and the sheer will to learn, just like us. But here's the real magic. Deep learning, intriguing tone. Deep learning is like the grand wizard of the neural network realm. It's where things get seriously impressive. Deep learning is a subset of machine learning, which in turn is a subset of AI. However, deep learning takes inspiration from the workings of our brain in a way that no other field does. It involves neural networks with several layers. These are known as deep neural networks. Just picture it as a multi-layered web of nodes, each node representing an artificial neuron, and each layer performing a specific kind of transformation or computation on the data. The deep in deep learning isn't a reference to any profound wisdom. Instead, it stands for this idea of stacked layers. We're talking about neural networks that have not one, not two, but numerous layers. And with each layer, the network learns more about the data it's handling. Now, here's where it gets interesting. Each layer in a deep neural network gradually extracts higher-level features from the input. For instance, in image processing, an initial layer might recognize edges, while later layers might identify patterns, shapes, or specific objects. Excited tone. And what's truly magical about deep learning is the myriad of applications it has in the real world. It's deep learning that's behind the scenes when you see self-driving cars skillfully navigating bustling streets, making split-second decisions. It's deep learning that powers your virtual assistants, enabling them to understand and respond to your voice commands. From detecting diseases by analyzing medical images to composing original music, deep learning is at the heart of these advancements. But remember, deep learning, like any magic, requires a lot of resources. It needs vast amounts of data and substantial computational power. But the results, as we see around us, are nothing short of magical. From self-driving cars navigating bustling streets to virtual assistants composing music, deep learning is at the heart of these advancements. So as we step into this future, let's embrace the magic of deep learning. As we wrap up today's episode, remember this. Neural networks are far more than mere mathematical models. They are, in fact, a testament to human ingenuity, a reflection of our ceaseless quest to understand and replicate the intricate workings of our own brain. They embody our audacious ambition to peek into the future, to harness the potential of artificial intelligence for transformative changes. Neural networks are the magic wand that turns the impossible into possible, the unknown into known, and the complex into comprehensible. They are the stepping stones that let us traverse the realms of AI, from the shores of basic understanding to the exciting heights of professional expertise. But our journey doesn't end here. The coming episodes will delve even deeper into the enigmatic world of artificial intelligence. We'll uncover more gems, explore more paths, and continue to unravel the mysteries of this captivating field. Please subscribe to our channel so we can make more exciting tutorials like this. Until next time, keep those curious neurons of yours firing away. See you in the next episode.